Hi guys, so today we're going to be moving on to the sine rule, which is another vital part of trigonometry. So essentially the sine rule is when we use the different angles and sides in a non-right angle triangle to determine other side lengths. So let's say we have a triangle over here. So the angles, let's say that none of them are 90 degrees. Let's say this is like 54 degrees. This is 72 degrees. And we know this side length over here is 14. But we want to find what side length x is. So the sine rule essentially uses the relationship between a side and its corresponding angle to link that to other sides and corresponding angles and therefore make judgments. So basically what I'm saying is that the sine rule states that a over sine A is equal to b over sine B, which is also equal to c over sine C. So what that essentially means is that if you have a triangle, let's say, wait, let me just draw a better one. This triangle over here, if you have sides A, B, and C, the corresponding angles are the opposite sides. So the opposite to A happens to be this angle over here. So we would say that this here is angle A. Then the opposite to B is the opposite angle, which is this one, so B, and this is C. So basically, the sine of this angle divided by the side length, or the other way around, it doesn't really matter. Like you could write this as sine A over A is equal to sine B over B, which is equal to sine C over C. If you just take the reciprocal of all of them, that would be the result. So you could take the sine of this angle divided by the side length, and you get a ratio that you can apply to the other ones. So for this particular instance, for this triangle, we can just say that, well, we have, let's say A is equal to 14, which is this side over here. So the corresponding angle, obviously, is 72 degrees. Now we want to be able to find out what x here is. So we know that B, which is our side length that we want to find out, is x. So the corresponding angle is 54 degrees. Now we could also find C, which in this case would be this angle and this side length, y. But let's stick with x for now. So plugging it into our equation, we get 14 over sine 72 is equal to x over sine 54. And we just rearrange after that. And we get that x is equal to 14 sine 54 over sine 72, which is equal to, let me just put that in right now, sine 54 divided by sine 72. So that gives us 11.9 as our answer. And we can do this for the opposite way. So let's say we're given that, we're given another triangle. I'm just gonna erase this and make room for one. So we're given another triangle, oops. And we're told that this is 37 degrees and this here is x degrees, but we're given that this is 12 and this is 15. And we're supposed to find x. Well, if we use the opposite of that equation, in that we put the side length as 12 for A, sine of that would be sine x, which is equal to B, which is 15, over the corresponding angle, is just 37. So you can let any of them be A, B, or C. It's just make sure you use the right angle along with that side. So we can rearrange and get that sine x is equal to 12 sine 37 over 15, which is equal to 12 sine 37 divided by 15, which is equal to 0.481. And then we're going to do the inverse of sine. So basically the inverse of sine just takes the angle and takes the value and finds the corresponding angle that gives that value. So x is equal to the inverse of sine of 0.481, which is equal to, and if we put that in our calculator, we get 28.75. So x is equal to 28.75 degrees. And as we can see, this works for any triangle. And all we need to know is either know two angles and a side length or two side lengths and an angle, and we can find different values. So let's try this one example. So we're asked to find x, and the information we're given is one side length and two angles. So this is enough to find another side length. So the first thing you have to realize is which ratio do we have for sure? And the answer is we've got this side length and we've got its corresponding angle, so we can use this ratio. And the other thing is that we have the angle of the opposite angle to the side we want to find, so we got everything we need to know. So we're going to start off by finding out what this ratio is. And if we remember from our equation for the sine rule, that the first part is a over sine a, or sine a over a, it doesn't really matter. So that gives us 23, which is our a, over sine of the angle corresponding, which is 35. And that's equal to b over sine b. In this case, b is our side length of x, which we do not know. And we're dividing it by the sine of the opposite angle, which is 21 degrees. If we rearrange, we get x is equal to 23 sine 21 over sine of 35. Which is equal to, and if we just put it in the calculator, we get 23 times sine 21 over sine 35 is equal to 14.37 cm, or whatever units they're using because they haven't specified. And that's our answer. So in the next video, we're going to look over another rule that's really helpful to use, and then we might go into previous videos on how we can combine the different rules and therefore come to effective conclusions. Because trigonometry, when you can combine all these rules together, you can pretty much find anything with really any information. So thanks so much for watching this video, and see you in the next one.